Class, our first experiment today is a quantification experiment. What we're going to quantify is nickel 2 nitrate or nickel 2 ions in solution. And we're going to use the fact that the solutions are green to do that. What we're going to do is we're going to actually figure out the concentration of nickel in 24 different samples. That's our goal. So in order to measure and determine the concentration of nickel in each of these unknown samples, which we have 24 to find out, what we do is we make up solutions of known concentration of nickel 2+ ions, which we make from using nickel nitrate. And to do that, we use volumetric flasks. A volumetric flask is a flask that holds a certain known amount of solution. So what we do is we weigh out our nickel nitrate, so we know the mass of the nickel nitrate, and we dissolve that up in a beaker with some water, and we pour it in here, and then rinse the beaker into here. And then you fill it up with water up to, there's a line right here, and if you fill it up right to that line, then that flask holds exactly the amount it says, which is 250 milliliters. And if you ever use one of these, it has a little TC marker on there, which means to contain, which means if you fill it up to the mark, as we say, then it contains that amount. So what we've done is we've done that for 5 different solutions. We've weighed out a mass of nickel nitrate, hexahydrate, added that into our flask, filled up to the mark, and we've made 5 different solutions of different concentrations for which we know the mass, and therefore we know the volume, and so therefore we're going to know the concentrations of those. And so we put those in cuvettes. What we're going to do is we're first going to measure the absorbance using the spectrometer of these solutions and use that to make a working curve or a standard curve. And then after we have the standard curve, we're going to then measure the absorptivity of all of our unknowns and use that to then determine their concentration. Okay, so we're ready now to do the experiment. We're ready to make our measurements. And what we're going to be doing is we're going to be using the PerkinElmer Lambda spectrometer, which is a diode array spectrometer. We're going to set that to the wavelength at which we have the maximum absorbance for the nickel nitrate. And we're going to look at our samples. First, what we're going to do is we're going to do our blank and our 5 known concentration samples, our standard samples. We'll do those first, and then we'll make a standard curve. But then after that, what we'll do is we'll analyze all 24 of our unknown samples. So it's time to make the measurements. Okay, so we're going to use the PerkinElmer Lambda Bio spectrometer. And what we do is we're going to have to choose what we want to measure. So we're going to choose one for standard measurements. And we're going to measure the absorption at a single wavelength. So we'll pick one. And the wavelength that we found to be the maximum earlier on was 394 nanometers. So we're going to choose 394 nanometers. And then we're going to be good to go. So push that. And before we can measure our samples, we need to tell the spectrometer what the energy going to the detector is with no nickel in our sample. And to do that, we use something called a blank. It's a solution that has everything in it except the compound you care about. And so now we're going to do just water. And so normally a blank is the same kind of cuvette, maybe the same cuvette, and the solvent that you're using. So we'll put that in the cell holder. And we're going to push this button here, which means 0 absorbance, 100% transmittance, which means that's the sample that has nothing absorbing at the wavelength that you care about. Okay, so that's recorded, and now our absorbance measurement is 0, as it should be. And so that's actually our first data point, that with no nickel in there, you have no absorbance at 394 nanometers, which is kind of the point. Okay, so now what we're going to do is we're going to do our 5, we have our 5 samples, A through E, and we're going to measure each of those in turn, starting with the least concentrated, E. So we're doing sample E, so you just put that in there, press record, and that has an absorbance of 0.212 absorbance units. Okay. Next we're going to do sample D. We're writing these down as we go, as you will. Sample D is 0.398. Sample C, these are, remember, getting progressively more concentrated, so the absorbance is going up. That's 0.621. Okay, and then sample B is 0.827. And remember that, as we talked about earlier, The percentage of light going through, if you have an absorbance of 1, is only around 10% of the light gets through the sample. And so we don't want to go, you go a little bit more than 1, but you don't have absorbance values much greater than 1. So this is sample A, our most concentrated one, and it's 1.002. So it's not actually close to 1 for any particular reason, it just happened to be that. So that's a coincidence from the samples we made up. Okay, so we're done measuring our standard solutions, and now what we're going to do next is we're going to develop our standard curve using this information, the masses of the compounds, and doing that in Excel. So that's what we're going to do next.